So before we finish this session here, so probably the final thing I just want to discuss, because the next session we are going to getting into the final class for the subnetting, where we get into the most final and the last final class and the main class, I can say, because the first two classes, the previous class and this class, is going to lay very good foundations for your subnetting. So when you have a proper foundations on how the calculation process goes, it becomes very easy for you to minimize your time in calculating the subnetting and understanding the concepts. Okay, so there's a final step where I'll be discussing how the default design networks, how to design them, and some VLSN calculations. And also we'll try to understand how the questions will be asked in your certifications or interviews, submitting bits, and how to solve them. Probably you'll find some more questions on subnetting. So that is the final step actually, which is very important, but these two classes are foundations. So before I just finish off this session here, I just want to finally discuss one thing, that is slash value. So if you remember, in all our examples, whenever we are trying to write the examples here, we are going to write this as slash value slash 26. That is nothing but total network bits. So when you're writing total network bits, we are writing in the form of slash value. Now, what is exactly that slash value represents? So finally, we'll summarize what is slash value. Slash value, in general, it represents your total network bits. It represents your total network bits. Like by default, A class, B class, C class. A class by default, the subnet mask is 255000, and the default subnet mask for B class is 2552550, and the default subnet mask for C class is 255255250. Okay, so now, and we also know that each and every portion represents 8 bits. So this is something what we learn in our basic IP addressing class. So now IP addressing is very basic for us now. So because we are getting into some advanced IP addressing called subnetting concepts, but still you should remember the basics as well. So by default, A class contains 8 network bits, B class contains 16 network bits, and C class contains 24 network bits. So now, if I just take an example, I have a scenario diagram. When you get into some production networks, when you see some scenario diagrams, or even when you face certification questions, you'll be given a question like this. You have a router connecting to some devices here, and the IP address on this device is 192.168.1.10 is the IP address, and there is no subnet mask mentioned here in the diagram. Let's say I have given you a scenario and I did not mention you a subnet mask. Now what in general I will understand? I'll just try to figure out, if I just see any IP address, like even if I go here, but definitely you have to give IP address, but in documentations, in scenarios, we don't really give some more in detail information here. So probably you have seen, if I give a diagram to you and if I ask you a question that do something, and you are going to troubleshoot it, and you are going to find out what is the IP address, and you have seen the documentation, and you have seen this documentation diagram have this IP address, but there's no subnet mask mentioned. So what I'm going to assume that it's a 192. So 192 comes in the C class range, and I'm going to assume it as default subnet mask. That is something what I understand in general. Okay, so whenever you're writing default subnet mask, which means the range starts from 0, ends on 255. Okay, but in case, as per your real production network, you're not using the default C class subnet mask, you're actually using the subnet mask of 255, 255, 255, 192 as a subnet mask. But in case if you are using anything other than default subnet mask, then it is mandatory for you to mention. Because whenever I see any address with 192.168.1.10, I will simply assume as the default subnet mask. So that is something 0, which I really using the default subnet mask, which means if you are using other than default, it becomes mandatory for you to mention. But defining the subnet mask in this format is a little bit much lengthier. In the documentations, in the scenario diagrams, probably you'll see the same thing written as like this. So it's another representation of this. So now you can ask me, where is the subnet mask written here? Because if there is no subnet mask, I cannot understand the range, because the subnet mask tells the size of the network. Subnet mask tells where the IP address starts and where it ends, what is the network ID, what is the broadcast ID, all these things. Without subnet mask, it becomes really difficult. It's actually, I cannot easily find out how the range is identified. So whenever you write this subnet mask, 255 represents 8 bits, 255 represents 8 bits, 255 represents 8 bits, and 192 represents 2 bits. If you remember our table here, 192 represents 2 bits. Means there are 2 network bits. So which means total there are 8 plus 8, 16, 16 plus 8, 60, 24, 24 plus 2. Total there are 24 network bits. So instead of writing in this format, we are simply writing in this format. So slash value represents total network bits. And when we are writing the subnet mask is nothing but adding your network bits, right? You are just converting your network binary to decimal. So if you write like this, this is correct. But in practical, when we design, when we apply to any device, we assign in this format. But when you see most of the documentation scenarios, even in the examinations, or even exams, or in documentations of any real production networks, they will not write in this format. So normally you don't see in this format. Instead, you'll see it is written like this with /26. Okay, so which means it's another way of writing your subnet mask. So subnet mask is mandatory to mention, but we are not writing the complete subnet mask. We are just representing as total network bits. That's what we are doing here. Okay. So I hope you got the understanding why we write the slash value, because whenever you see this is something. So the default slash value of A class is /8 because there is only one network portion. The default slash value for B class is /16. And the default slash value is /24, which means there are by default 24 network bits. Remaining all are 8. There are 16 network bits and 16 host bits. There are 8 network bits and 24. The same thing what we learn, but we are just trying to understand why exactly you see in slash format. Whenever you see slash format, you need to understand that it is actually representing your subnet mask only. So that's the reason if you see my examples here, whenever I write the range, I made the habit of writing slash value in the last. So this is something which you need to make the habit of writing. Whenever you write the range, you make sure that you also write the slash value in the end. Based on this, I can understand /26 means there are 8, 8, 8, 24 plus 2 bits host. Similarly, if I take another example here, when I say /23 means 8870, which means 8, 8, 7 means 254, 0. So finally, what we do is we'll try to do some examples, some conversions, some practice I can say. So I'll give some examples here, /20. Okay. So I'll just try to write down here some exercises on converting the slash value. So /20, I can say /18 and /23 /25. Anyway, I'm just giving some exercises for you. So when you can just note down these exercises. So to just have a conversion method. I'll do 2-3 examples for understanding. /19, let's say /28, /29, and then /30, and then /22, and then /20. I think I did /20. Okay, so probably you can just take down this example. So I'll do any one. Let's say I'll do /23, /19, or any other example. So let me do some examples here. So I'm going to say /20. So whenever you see slash value, you should be in a position to find what is the equivalent subnet mask for that. So in my example, it is whenever we are writing, so /20 means in one portion you cannot write more than 8 bits. So again, I'm writing 8 bits. So 8 plus 8 becomes 16. So I can write 4, which means 20. 8 plus 8, 16. 16 plus 4, 20. And if you don't have anything, just write 0. And you have to refer the table, this table. If you remember our table here, so 8 bits represents 255 and 4 bits represents 240. That's what I am doing. So whenever you see /20, you have to understand that okay, 20 represents the subnet mask of 255, 255, 240.0. This is very important to have understanding. Okay. So similarly, if I take one more example, /17, So slash 17 means 8 bits, 8 bits. 8 plus 8 16, 16 plus 1 bit and then 0. So if you add 8 bits, 1 bit means 128.0. So whenever I write slash 17, you have to understand this is the equivalent subnet mask of slash 17. So similar way, if I take one more example, slash 29, 8 bits, 8 bits, 8 bits, 8 3 is 24, 24 plus 5 becomes 29. So when I add 8 bits, 255, 255, 255, and then 248, I think so. Let me check. 4 bits is 240, so 8 bits, 248. I think I'm correct. So just confirm 5 bits, nothing but 248. So some examples. So finally, what I want to say is, whenever you see subnet mask, whenever you see the address in this format, you should be in a position to convert into equivalent network bits and host bits. Like when I say 255, 255, 240.0, I should understand that, okay, there are 8 bits, there are 4 bits, which means it's nothing but slash 22, which means there are 22 network bits and remaining 10 are host bits. So this understanding is very important whenever you are designing, whenever you see any production network scenarios, whenever you see this diagram. So it's very important to have a clear idea on conversion of some subnet mask into bits, this format. Similar way, whenever you see slash value, you should have a clear understanding on what is the equivalent subnet mask. These conversions are important. So probably you can take some examples like the examples which I wrote here. You can just practice these examples to get your answers. So just take any slash value, anything less than 30, you can take and you can find the equivalent subnet mask. Okay, so these exercises will give some good practice. Okay, so we are done with, up to now we are done with our FLSM calculations by using a C class. We did some examples, like in the first video we did the example of requirement of 40 hosts, and in the next video I also explained one more example with a requirement of 12 hosts, I think so, but you can practice with 30 hosts, any other numbers, just to have some practice. And next we have seen how they are different networks. We have seen that anything starting with 0 to 63 is one network if I use this subnet mask, and if I use default subnet mask, anything starting from 0 to 255 is one network, and how they are different. And I cannot use 64, I cannot use 128, I cannot use 192 if I use this subnet mask, because according to this subnet mask, these are network IDs and I cannot use network IDs, and these are broadcast IDs, and whatever the addresses coming in between, those are the addresses which are valid addresses. Okay, and we have seen the difference on that. And then we have moved to some B class examples where we have seen how to write the range for bigger numbers. So whenever we write a range for bigger numbers, we have to use 2 to the power of h divided by 256. So based on that, it's required. So you have to increment on the third portion whenever you get any number more than 256 or less than 65,536. So similar way, the same thing we do for A class also. Like you can see, once you finish this part, you have to come to the next part and you have to write the same addresses. Some examples again you can probably work on. And then finally we have discussed some slash values. Slash value, that is something what you'll find in documentations. In most of the scenario diagrams, you will not see the subnet mask, and instead of subnet mask, we define the slash value. So slash value is nothing but representing your subnet mask, but it's another way or short way of writing your subnet mask. So you should be in a very good position to know what is the equivalent subnet mask for this value, and what is the, whenever you see subnet mask, you should be in a position to know equivalent network bits and host bits. So these concepts, this understanding is very important. And finally, in the last session, the next session which we'll be discussing, that session is going to explain you some shortcut methods of doing all these calculations. But again, remember one thing, before you get into that particular section, you have to make sure that you are much comfortable with all these things, not only understanding along with practicing, because simply listening to the class and assuming that you understood all the concept and you follow it, it's not help you, and you'll find it a little bit more problems, especially when you start doing the things. So when you start doing the things, you'll feel it more better. Okay, so I really suggest you to try some examples working on. You can possibly try the same examples what I used, okay, without saying, and in case if you find any difficulty, you can try some other examples. So try to make sure that you work on some at least 2-3 examples to make sure that you are much comfortable with these calculations. And in the last part, we are going to getting into some shortcut methods, VLSM, and also we'll discuss on how to solve bits, the questions, what type of questions you'll find in your examinations or in the interviews when you face in the written test, how to solve them, and how we can save your time, a lot of time in solving this. What are the shortcut methods to apply that? But again, to master that particular shortcut method, you should master a step-by-step method. That is mandatory. And many people I have seen, they probably try to skip this step-by-step method once they really know the shortcut method. But I really strongly suggest you to just follow step-by-step method to have a more clear understanding. Because if you don't do this step-by-step method, you still have some confusions, which again in turn affect your shortcut method also. So which I really don't want. So probably once you master this step-by-step method, now the final thing is you need to only use shortcut method in the implementations, in the examinations. You just need to use only shortcut methods finally. You don't really need to go with all the step-by-step method, but initially you have to follow. That is something which I strongly suggest you. Okay, so probably I'll see you in the next video. Okay, the next session where we'll get into some more advanced submitting. Okay, thank you.